Hello students, Dr. Bhavani Regmi here. Today we are going to start a new chapter, chapter 5 about chemical reactions. Having learned about atoms, ionic compounds and covalent compounds, their structures in our earlier chapters from 2 to 4, now we can turn our attention towards chemical reactions. Okay, so in this chapter we will explore about chemical reactions, how to balance the chemical equation, how to recognize different kinds of chemical reactions, and solve the math problems related with the reaction. Okay, so in today's lesson, let's introduce ourselves with the chemical reaction. First of all, it is important for you to understand that chemical reactions means they are a chemical change. Okay, if you remember physical chains and chemical chains we discussed, okay, the chemical reactions involve formation of completely new compounds. There is change in the composition of atoms, right? So we call it chemical reaction. So a chemical change or a chemical reaction converts one substance into another. Okay, so and it involve, so we generally write the reactants on the left hand side of the chemical reaction and products on the right hand side of the chemical reaction. Okay, so reactants are the starting material that we need to combine them, mix them well, and when the chemical reaction takes place, when the chemical change takes place, then form the products, right? So the products are the result after the chemical reaction. So at molecular level, what we see is the bond between the elements, okay, the bond between the atoms in a compound is broken down during a chemical reaction. And when these bonds are broken down, they will reorganize and form a new bonds in the product. That is how a chemical reaction takes place. So let's say here in example, we have molecule of methane, CH4 molecule, and we have some molecule of oxygen. Oxygen and methane, these are the starting material, right? We call them reactants. When they combine with each other, the bonds of carbon and hydrogen break down here and the new bond between the carbon and oxygen form. As a result, we end up making carbon dioxide. You see here linear carbon dioxide with two new bonds, and also the water molecule, which is a new product here. Right? So from reactant methane and oxygen, after reaction we got products water and CO2, carbon dioxide. So let us now look on, okay, how do we express that chemical reaction? Right? Whenever we have to express that chemical reaction, we write them in chemical equation. We express those symbols and formulas to represent the chemical reaction. We need to have the correct formula for them. Okay, that's why it is important to know the formula, how the combination takes place to form a compound, which we learn in earlier chapters. Okay, and then we will learn to put them together and balance them. Why do we need to balance the equation? Because the chemical reactions obey the law of conservation of mass. It states that atoms cannot be created nor destroyed in a chemical reaction. They are just rearranged. The atom by itself, like the nucleus and the electrons around that structure of atom, that does not be created or destroyed. It is just the rearrangement. New bonds form, the old bonds are broken down. That is all take place during the chemical reaction. Okay, so that's why we use the coefficient here, the numbers in front of those molecules, to balance our equation, to show that we do have equal number of each element before the reaction and after the reaction. So you saw here, we see here an arrow that differentiate reactants on the left hand side and products on the right hand side. A balanced equation will have the same number of elements on each side. Let's see here with an example. Once we place 2 in front of oxygen molecule here and 2 in front of water molecule here, now we can count. All together we have only 1 carbon on both hand side. All together we have 4 hydrogen atoms on the left hand side, and this 2 times 2 makes 4. We have now 4 hydrogen on the right hand side. Oxygen we can count. We have 2 times 2, 4 oxygen atoms on right hand side. 2 times 1 is 2 here, plus 2, total 4 oxygen atoms on the right hand side. Okay, so a balanced equation has the same number of atoms of each element on both sides of the equation. We just saw an example that has the balanced equation here, right? You might be wondering, how do I balance it if our equation is not already balanced? Rest assured, I am going to show you how to balance the equation. Let's say we have an equation something like this. We have C3H8 and oxygen molecule. So these two substance, starting material, reactants will react together to form the products carbon dioxide and water molecule. Okay, and another information from a chemical equation that we get is we always mention the physical states of those reactants and product. Okay, you see here it is written G in parentheses because all of them are gases. If we have something in solution form, we write AQ. Okay, so let me write it here. If we have something in solution form, we go with the subscript AQ to mention that it is aqueous solution. Okay, if we have gases, we write G. If we have solid, okay, we mix the powders and we see the reaction, then it is solid, so we represent that with letter S, lowercase s. And if it is purely liquid, then we write letter L. Okay, so these are the 4 physical states that we might need to write correctly when we are writing a chemical equation. Okay, and now how do we start to balance this equation? Okay, if you are wondering, the C3H8 is a propane gas, generally propane gas that we have in propane tank. When we burn the propane gas in air, it is the oxygen component of the air that will react with our propane. When these two mix up, they will form they will generate high energy, they will make flame, right? And we cook food on that. And on side by side, they will make carbon dioxide gas and water. This water at high temp, since it is occurring at high temperature, will convert into gas form. So we have a gas here. Okay, if it forms in liquid form, then we generally write L in such equations. Okay, now back to how to balance this equation. So, in order to balance, okay, how are we going to do this? First of all, we need to make sure that our formulas are correct. In this case, it is correct. Okay, and then we can balance one element at a time by adding a coefficient in front of each chemical reagent. And there is a technique to do it easy. We will start with the atoms that show up once on each side first. We will leave the element that appears on the most for the end. And once we write everything, we do not change the chemical formula. We are allowed to just write the coefficient, means we are multiplying those formulas by certain numbers. We are not allowed to change these subscripts down here. Okay, and if a coefficient involves a fraction, then we need to finish up balancing the equation by multiplying all coefficient by a factor to get rid of the fraction. And finally, we have to check our answer, just double check whether all are balanced. Okay, so that is a complete procedure how to balance a reaction. Let's now apply this procedure on our task. Okay, first of all, I can see here, okay, I will count the number of element on both sides and see whether it is balanced or not. Okay, so this is preliminary analysis. We have 3 carbon. The subscript always give you the number of atoms present there. Okay, so we have here 3 carbon, and on the right hand side I can see only 1 carbon. So this is, right away you can say it is not a balanced equation. You need to do balancing them. If you want to further check, hydrogen, there are 8 of them. Hydrogen, just 2 of them on the right hand side. Oxygen, we have 2 of them on the left, and we have 2 plus 1, okay, on the right hand side. So none of these elements are balanced. We need to balance all of them. So let's try to balance them. And according to the rule, it says that it will be a lot easy if we start with the atom that show up once on each side first. Okay, if you look here, oxygen is here and oxygen is on the 2 places. So we want to leave oxygen on the last. We want to balance the carbon first, okay, because there is only 1 place. So this one, I'm now teaching you how to do step by step. Once you do a couple of practices, you will be pro on it and you can do it directly. Okay, but for now I'm teaching you the basic foundation. So I will write these steps. Okay, I will write the elements. I will keep track of each of the element on both sides, and then we will solve this. So I have on the left hand side, so I'm writing these guys on the left hand side, these guys I'm keeping track on the right hand side. Okay, on left hand side I have 3 carbon, so I will start with writing I have 3 carbon on the left. I have only 1 carbon on the right, so I need to multiply the carbon on the right by 3, because 1 times 3 is equal to 3, and now I can balance, right? So since I'm multiplying this 1 by 3, 3 is my coefficient, so I will write 3 here. Okay, it means I'm multiplying CO2 by 3. So now let's check for hydrogen. Okay, we are good for carbon. Now let's check for hydrogen. Hydrogen, I have 8 of them on the left hand side. I have 2 of them on the right hand side. 8 versus 2. Right away you see I need to multiply this by 4 in order to get the 8. Right? So now once I multiply by 4, my hydrogen will be balanced. So my hydrogen on the right hand side is with the water, so I multiply this by 4. When I multiply by 4, I will make changes not only on hydrogen but also in oxygen. Let's see how. So for oxygen on the left hand side I have 2, so I'm writing 2. On the right hand side, okay, in the product side, I have here 3 times 2. The coefficient and the subscript we have to multiply to get the number of atoms. So 3 times 2, I have 6, and 2, and here is a 1, right? So 4 times 1 is 4. So 6 plus 4, I have altogether 10 oxygen atoms on the right hand side. That's how we get 10 here, right? But we have just 2 on the left. So the answer is multiply by the 5 here to get the 10. Right? And now you can see I have to multiply this by 5. 5 is on the left hand side and to the oxygen, so I multiply the oxygen on the left hand side by 5. Okay, now you can check back. We put the coefficient, and our coefficient are not fraction, they are whole number, so we do not need to do the step number 4. Sometimes we have to do this step, okay, depending on the equation. Right here we don't have to do that. And now let's check whether our answer is correct. I have 3 carbon, good. I have 8 hydrogen, 4 times 2, 8 hydrogen, good. I have 5 times 2 oxygen atoms. I have 3 times 2 is 6. 6 plus 4 is 10. 10 on the right, 10 on the left. We are good. So this equation is balanced this way. Okay, so please take a moment at first, practice this way, breaking down your compound into carbon, hydrogen, and oxygen, and practice this way to balance. Once you understand a couple of examples, you can directly write your coefficient in front of them without skipping those steps, okay, without following each of these baby steps I just show you. Okay, so I think you are excited to try one of the reaction by yourself. So let's go for that. Can you go ahead and try this equation to balance? Okay, this equation is not balanced. I can see I have 5 carbon here on the left hand side. I have 1 carbon on the right hand side, right? It is a similar question we just did. You can write carbon, hydrogen, right, and oxygen on both hand side. So first 5 carbon, okay, do not fill up all right now, just fill up the carbon. And then you have 1 carbon on the right hand side, so multiply this by 5, right? So I'm writing 5 here. Once you have 5 on the right hand side, go back to look on your hydrogen. You have 12 of them. On the right hand side you have just 2, so 2 means you have to multiply by 6 to get 12, so you multiply by 6 here. Now go back and check for oxygen. You have just 2. On the right hand side you have 5 times 2 is 10, right, and 6 times 1 is 6, so 10 here plus 6 there, total is 16. Now you go back. Here we have 2 on the left, 16 on the right. So it makes sense that if you multiply by 8, you will have 16 on the left, 16 on the right, and it will be a balanced chemical equation. Okay, so I showed you how to balance this equation. You can check your answer against my answer here. Now, for any reactions where we have the hydrocarbon, okay, carbon and hydrogen, these are the reactants and they are reacting with oxygen to form carbon dioxide and water. We can follow this method and it's a lot easier doing this way. Okay, some other reactions we may not need to break them down into these baby steps. We can directly look on the parts of them and balance them. Now I'm going to teach you that. Okay, so let's see if we have a reaction which we can break down into cation and anions part. Okay, so you can either follow the earlier method, okay, and go by one, or you can look a little bit bigger subset and try to balance that smaller group at a time. Okay, what do I mean? Let me show you here with this example. I have here calcium and then I have here OH. right? So calcium, I have one atom of calcium on the left hand side. I have one atom of calcium on the right hand side. I'm good for calcium, right? Now let's go for checking Cl. Chlorine, I have two on the right hand side. I have only one chlorine atom on the left hand side. Right away, you see here, this is 1. I have here 2 on the right. It means I need to multiply by 2 on the left. You get that idea. Okay, now since you put 2 on the HCl, now you make changes on the number of hydrogen atoms. Right? So now you can go and track that hydrogen atoms. Here you have 2 hydrogen, right? Here 2 plus 2, 4. So we have total 4 hydrogen atom on the left hand side. We have just 2 on the right hand side. So multiply that by 2. 2 times 2 becomes 4. Now we have 4 hydrogen on the right hand side. So hydrogen is balanced. And most likely your oxygen is already balanced. Let's see that. So you have oxygen 2 here, right? All together you have 2 oxygen on the left hand side. On the right hand side, you have 2 times 1, which is again 2 on the right hand side. So oxygen is already balanced. So this is how you can balance the equation. Okay, so if the things are with some cations and anions, it's a lot easier by going this method. Let me show you one more example so that you become pro on balancing equation. Please give me one more equation. Let's see. Okay, so we have here, the physical states is missing. A correct chemical equation should have a physical states with them. Okay, subscripts and written with the letters there. Anyway, we have P4, this is phosphorus, okay, P4 plus Cl2, 2 reactants combining to make the product PCl3. So I have here phosphorus, 4 of them. Here I have just 1 phosphorus, right? So right away you need to multiply the right hand side by 4. You get that, right? So let's multiply by that. Now phosphorus is 4 on the both hand side. Phosphorus is good, equal number of atoms. What about the chlorine? Chlorine on the left hand side, the chlorine atom, we have 2 of them. On the right hand side, now 4 times 3 is 12. So we have 12 chlorine atoms on the right hand side. What can we do? We can multiply the left hand side by 6. Now we have 12 on the left, 12 on the right. Everyone is happy. Everyone is balanced, right? So that is how we balance the equation. So I have some more equations for you on the next slide for you to practice. So please practice. There are more equations. Okay, so yeah, I can see right away. It looks like the first one is balanced, right? We have 1, 1, 1 and then hydrogen 2 and oxygen. This is already balanced. Okay, you can pause your video, practice these, and you can come back and check my answer. Okay, so I will just pick up few questions from here and leave for you to practice. Let me go. This is aluminum here, oxygen, 2 aluminum here. I have 3 oxygen. So whenever you see 2 on the one side, 3 on the other, in order to make both of them equal, you want to make them 6. Okay, that is the hint. So if you multiply this by 2, oxygen becomes 2 times 3, 6. If you multiply by 3, now oxygen is 6 on the left. Okay, every time you see 2 or 3 on 2 sides of the arrow, go for trying to make them 6. That will make your life easy. And now you just have to deal with aluminum. I have 2 times 2, 4 on the right hand side. So multiply by 4 on the left hand side. Voila, you have the correct balanced equation here. Okay, so I have CH3, CH3. It is, this question is something that I would like to work for you. Okay, I have here 2 carbon. Okay, so instead of writing C2H6, it is written CH3, CH3. Both mean the same thing. if the question comes like that, if the question has C2H6 formula, okay, it means it has 2 carbon and 6 hydrogen, and same is true here, 2 carbon and 6 hydrogen, right? So you can get the question with this or that, it's the same thing. Now let's look on the question itself. The question is, I have 2 carbon on the left hand side, I have only 1 on the right. So right away you can multiply by 2, right? We deal with carbon. Now the procedure says deal with hydrogen. I have 6 on the left, I have 2 on the right, so I will multiply by 3 on the right, right? You are good with hydrogen. Okay, sometimes students just do this and then they think everything is balanced and they leave out. Don't leave out. You are not done yet. You have to look for oxygen too. And for oxygen, you have 2 on the left. You have 2 times 2, 4 plus 3. So 7 on the right hand side. Okay, so you have 7 on the right hand side. Oh, this time you have got an odd number. Right? Whenever you get an odd number, you have to pay a little more attention. So we have 7 on the right hand side. So if you multiply by 7 by 2, okay, because we have 2 on the left hand side, so that 2 and that 2, when we multiply, they will cancel out, and now you will have a 7. Right? So 7 on the left, 7 on the right, that would be balance. But we cannot leave 7 by 2 as a fraction there. Okay, we are not supposed to write a fraction in an equation. We want to make them a whole number. Okay, so what is the solution here is, let's not, oh, I wanted to erase that, but I choose the white paint. Okay, sorry. So I had to choose that and write 2 here. Okay, O2. Now, in order to make a whole number, the solution we have is we will multiply all the members of the equation by 2. Okay, when we multiply everything by 2, now it will become 2C2H6 plus 7O2 plus 4, that gives 4CO2 plus 6H2O. Okay, so let me erase that. So what was the final answer? We had 2 here, we have 7 here. Okay, we had 2, and then 2 times 2 is 4 here, and then originally we had 3 times 2 is 6 here. So now we have whole number as a coefficient, and this is good. Okay, the last step that we took was to multiply everything by 2 because we wanted to cancel out the 2 on this denominator over here. Okay, we could not leave the fractions there. That's why we had to take this extra step, and I hope you understood that here. Okay, so please practice these other ones. Okay, for the last one, you can break down that as silver and nitrate ion, magnesium and chloride ion, and silver and chloride, magnesium and nitrate. In such questions, it will be a lot easy to handle NO3 all by itself than individual nitrogen and oxygen. Okay, what do I mean is, right away you see NO3, there are 1 of the polyatomic NO3, there are 2 polyatomic NO3 here because of the 2 here, right? So right away you multiply the first one by 2. Now nitrates, these guys are balanced. Now look on the silver. You just made, there are 2 silver atoms now. So it means you need to multiply AgCl by 2. Now you have 2 silver on the right. So these are good. Now look on the chlorine. 2 chlorine atom on the right hand side, 2 chlorine atom on the left hand side. all is done. You are good to go, right? So this is how we balance the chemical equation. Okay, please practice these chemical equations. There could be more equations in our practice worksheet. Practice them, and we will continue our exploration on chemical reaction in our second part. Okay.